Hey, what's up? It's your old pal, Mr. Cook. We're going to do 5.3 arithmetic sequences. So with arithmetic sequences, you guys should have been given a couple of formulas to use in class, and these ones are going to be given to you on your test as well. Just make sure you know how to use them. So with arithmetic sequences, you're given two formulas. One formula you're going to use to find the explicit rule. So remember that explicit rules are the equations that you get so that you can plug in any term number to get, the term itself. And here's how an explicit rule works for an arithmetic sequence. It's an is equal to a1 plus d times n minus 1. So first off, let's describe what an arithmetic sequence is, right? An arithmetic sequence is a sequence where you just keep adding or subtracting the same number over and over again to get to the next numbers in the pattern, okay? The number that you keep adding onto it, it could be a positive number or a negative number, is known as d, which is your common difference. Okay? So the common difference is the number that we keep adding to get to the next number in the sequence. Excuse me. All right, the other thing that you need to know is that A1 value there, A1 is the very first term in your sequence. In sequence. But when you know those two things, A1, the first term, and D, the common difference, that gives you your explicit rule. Okay, so that's one formula that I'm going to use for an arithmetic sequence for the explicit rule. The other one is the recursive rule. The recursive rule works a bit differently than an explicit rule. With an explicit rule, you can find any individual term that you want, as long as you know the term number. Whereas with the recursive rule, you find the next term after a previous term. So you need to know the previous term to get to the next term. And here's how the recursive rule is going to be given to you. An is equal to an minus 1 plus d. So d is still the common difference. It's the only number that you're going to have to plug in, but you're also going to be given a very first term. So it's kind of like a two-part equation. You need to know the common difference, and you need to know the first term number for this. But once you have that, you have your arithmetic sequence. So these are the formulas you're going to be given. You need to know how to use them. So let's use them for our little examples here in the homework. Determine if the sequence is arithmetic, so you keep adding or subtracting the same number. If it is, find the common difference, the d value. The next three terms, so just using the pattern, find the explicit formula, which we have right here, and then also the recursive formula, which we have right here. Then after that, find the 52nd term. Whenever you need to find like the 52nd term, the 88th term, whatever, always use the explicit rule for that, okay? So that's what we're going to be using for this one. Okay, first, let's really quickly just determine if both of these are arithmetic. So if I go from 12 to 22 to 32 to to 42, I keep adding 10 each time. So that number that I keep adding is my common difference. So D is equal to 10. That answers one question. Find the common difference. So find the next three terms. So the next three terms after that, I just keep adding 10. So it'd be 52, and then 62, and then 72. So those are my next three terms. Next, find the explicit formula. So with the explicit formula, I need to know the common difference, which I already know, 10, and the first term. To find the first term, it's just the first number in the list, 12. So that is my A1 value. So now I write up the explicit rule. So the explicit rule is an is equal to my first term, 12, plus my common difference, 10, times n minus 1. And I can just leave it like that if I want. That's my explicit rule. Sometimes some teachers ask you to distribute the 10 in there and combine like terms, but if you just leave it like that, it's the same thing. recursive formula. So now I write up my recursive rule. It's two parts, so you gotta do this first part as it's written. AN is equal to AN minus 1, and then plus the common difference. And remember that the common difference is 10, so plus 10. That's the first part. Then I need to list off the very first term. A1 is equal to, and remember my first term was 12. So there's my recursive rule right there. Now the last thing I need to do is find the 52nd term, and for that I use my explicit rule. So I go over to my explicit rule that I made, and I just plug in 52. So the 52nd term, A52, is equal to 12 plus 10 times 52 minus 1. And that's all calculator work at that point, right? So it's going to be 12 plus 10 times parentheses 52 minus 1. Enter, and I get 522. So that is my 52nd term. Let's do number 3. So if I go from negative 39 to negative 30, that's plus 9. Negative 30 to negative 21, that's plus 9. Negative 21 to negative 12, that's plus 9. So yep, it looks like it is indeed arithmetic. So this was arithmetic, this one's arithmetic. The common difference, the number that I keep adding, is 9. The next three numbers in the sequence, negative 12 plus 9 is negative 3. Negative 3 plus 9 is 6. Negative 6 plus 9 is 15. So there's the next three numbers in my sequence. Now for my explicit rule, I use my formula over here. So AN is equal to the first term, negative 39, plus the common difference, 9, times n minus 1. There's my explicit rule. Now let's write up the recursive rule. AN is equal to AN minus 1 plus my common difference, which is 9. So you just follow in the formula. And then the second part is the first term. So I listed off A1 is equal to negative 39. There we go, recursive rule, all done. Now I need to find the 52nd term. And to find the 52nd term, the best way to do that is to use the explicit rule. So do you know why you use this instead of this? It's because the recursive rule depends on the fact that you know the previous term. So that means that to know the 52nd term, I need to have the 51st term. And to have the 51st term, I need the 50th term. And to have the 50th term, I need the 49th term. All the way down to, when we have some of these. So it's just easier to use the explicit rule because we can jump ahead straight to the 52nd term by plugging in 52, and that's why we do it. So let's plug in 52. A52, the 52nd term, is equal to negative 39 plus 9 times 52 minus 1. And then just let your calculator do the rest. Negative 39 plus 9 times parentheses 52 minus 1. And that gives us 420. 420. Okay, so anyways. So that's 5.3, numbers 1 and 3. The rest of this stuff goes by pretty quick because we've already established what we need to do for a good chunk of this. It's just that it's going to look a little bit different. So remember like how back here I had that equation, that explicit rule, AN is equal to 12 plus 10 times n minus 1. If I did distribute this 10 in here, it would look something like this, okay? 12 plus 10 times n is 10n. 10 times negative 1 is negative 10. So if I add these two together, combine like terms, I end up with 12 minus 10, which is 2, plus 10n. So this is the exact same equation as this one. I've just distributed it through. I want you to notice something. The common difference, 10, is still the same number that's multiplying on the n here. Okay, that is the common difference. It's just that the first term is kind of a little bit different, okay? That's how it's going to be for numbers 5 and 7. Notice that the number that's on the n is still going to be the common difference. So from this equation, I can get the common difference. This is the explicit rule that they gave us. So when I need to find the common difference, It's just the number on the end. So D equals 10. There's my common difference. Then it says to find the first three terms, so I just plug in 1, 2, and 3. So if I plug in 1, for my first term I get, let's see here, negative 5 plus 10 times 1. So that's going to be negative 5 plus 10, which is 5. So the first number in my sequence is 5. And then you actually don't need to do like the rest of it, by plugging it in, because if you know the common difference is 10, that's what it keeps adding each time. So if I have 5 for my first term, my next term, if I add 10, is going to be 15. And if I add on 10 more, that gives me 25. And I can go further than that in the first three terms if I want. Just keep adding 10, so 35, 45, 55, and stuff. It's just the same pattern. So here's my sequence. I went a little beyond the first three terms. Now, if I need to find the 52nd term, what do? Plug 52 into the explicit rule, the one that we have. So if I plug in 52, A52 is equal to negative 5 plus 10 times 52. If I just type that into my calculator, what do I get? Negative 5 plus 10 times 52 equals 515. That's my 52nd term. Now we write up the recursive formula. Do you remember what we need for the recursive formula? We need the common difference and the first term. So we have the common difference, 10, and the first term right here in our sequence, 5. So let's write up the equation. AN equals AN minus 1 plus the common difference, which is 10, just using this part. And then list off the first term. The first term is 5. There's our recursive rule. Okay, that's the first problem. Now let's do the second one. So here's our explicit formula. The common difference is negative 4. Watch out for the sign, okay? Remember, if it's negative, you got to include that in there. So negative 4 for a common difference. Now let's find the sequence. So let's find the first term. Plug in 1. 22 minus 4 times 1. That's equal to 22 minus 4, which is 18. So 18 is our first number. Then we need to add on negative 4. In other words, just subtract 4 to get to the next term. So 18 minus 4 is 14. Minus 4 is 10. Minus 4 is 6. Minus 4 is 2. Minus 4 is negative 2. Minus 4 is negative 6, and so on. So there's our sequence. Now let's find the 52nd term. So to find the 52nd term, we plug in 52 to our explicit rule. So A52 is equal to 22 minus 4 times 52. And then I'm just going to let my calculator do the rest. So 22 minus 4 times 52. That's negative 186. There's our 52nd term. So if I continued this pattern all the way to the 52nd term, so 1, 2, 3, 4, 5, 6, 7, 8, 8th term, 9th term, 10th term, all the way to the 52nd term, it'd be negative 186. Now let's write up the recursive rule. So we use our little formula here for arithmetic sequences, and it looks like this. It's two parts. AN equals AN minus 1 plus the common difference. So that's going to be a negative 4. And, you could rewrite it if you wanted to. Let's see. Because plus negative 4, what's that the same as saying? It's just the same as saying minus 4. So I can just do a minus 4 on there if I want. Then I list off the first term. So A1 equals the first term, which is 18. There we go. There's our recursive rule. So my video is running a little bit late. I think I'm going to finish off the video here. So that's 1, 3, 5, and 7. And I'll start up on the recursive rule on the next video. All right, thanks.